There we go. Go ahead.
Got it. Okay.
Yep.
Yeah. So teaming up on this, I wanted to start it with risk assessment because that's the precursor that sets the stage before any kind of cable or brace gets installed. Whether it's formal or informal, you started off looking at a tree and determining, well, there's something about that tree that needs support. That is, in effect, a risk assessment process. And I'm also coming to realize that everything we do is risk assessment at some level, not just assessing the structural failure of a tree potential, but what's the potential of infection by a fungal disease if we're pruning a honey locust, or what are the safety risks on the job, like for electrical hazards, and even weather forecasting like today, like, well, what's the risk of damaging winds? That's everything that we do is risk assessment, figuring out what's the potential of an event to occur and the potential consequences or damage of that. Okay, next slide.
It's low. Come on. There we go.
And there is a really great basic tree risk assessment form that the ISA puts out that has all of these lines and categories in it. A really great tool to categorize and document risk in trees. If you go through this line by line, it leaves nothing untouched as far as a tree to consider what the risk is, from the ground all the way up to the tips of the branches. And it's just a great way to kind of walk yourself through like a systematic way so you can come out with a categorization of the risk on that tree. Okay, we can go to the next one. So what you do, that it's kind of worth a whole training. Actually, if you're going through or have been through the tree risk assessment qualification, it's all about how to use that form and go through the process. But what it aims at is to arrive at one of these 4 categories of risk for a tree, ranging from extreme, going through high, moderate to low, in describing the level of risk in a tree. And then the goal, once you have that, is to mitigate or to reduce the level of risk to the next lowest one, or maybe a couple risk layers down, but usually in the extreme cases, that's a removal, but maybe you can move a high risk tree to a moderate, or even a low risk, or a moderate to a low. But that's what mitigation is, just reducing the assessed risk level. Okay, next. So again, like I said, mitigation is just reducing risk level. And there's a whole bunch of tools in the toolbox that can make that possible. And as I noted down at the bottom, in the extreme ranked cases, usually tree removal is the only option for that. Like if a tree's already started to fail and peel apart and cabling wouldn't make sense, that's just a removal at that point. But in the less extreme cases where the risk ranking is not that high, you have options altogether, like move the target out of the way if the event of the tree failure happened where it wouldn't hit the target, like some picnic tables or something. Or you can restrict access to the vicinity around that tree, like at City of Minnetonka here. This is when Emily Ball was working for City of Minnetonka, and she's out at this big bur oak tree by the Civic Center there. So doing a risk assessment on that, one of the mitigations was reduce the access to the tree, and other kinds of things happen with this tree as well. There's also in the toolkit reduction pruning we'll talk about a little bit, and then installing tree support systems. That's just the broader overarching way of describing cabling and bracing, that captures all that in one term. Or you might have some combination of all the above. So this is why, I'm starting off here talking about risk assessment and mitigation, because cabling is just one piece in the toolbox of all these things involved with assessing and then mitigating risk. Okay, next. So there's definitely times where cabling does not make sense. And that's when residual risk is not lowered to an acceptable level through the mitigation. And what they mean in this terminology of the ISA risk assessment, whole science of it, is residual risk is the risk that remains after the mitigation has taken place. So you've done the risk assessment, arrived at some category like moderate risk, and then brought it down to a low level of risk. Well, it's still a low risk tree. It means there's some risk because every tree carries some kind of risk. Even a stump has some kind of risk because you could trip over it, or maybe walking by one of those sprouts pokes a person in the eye. So there's never zero risk with any tree, but it all comes down to what's the level of risk that's acceptable to the tree owner or manager. So that's what it really has to get at, is determining with the client what level of risk they're comfortable living with, and that they're clear there's never going to be zero risk until the stump is fully ground out and the tree is gone. Like, that's the only way to mitigate it down to zero risk. But we're trying to move it to a lower risk category. So as long as the client gets that, that's really what we're driving at here. Okay, next. Another time not to cable is when you're in your judgment, it's pointing towards there's no likelihood of regular monitoring, because best practice, through ISA or ANSI standards, is to have regular inspections of the cable system and the tree that it's been installed in. Like, you can see this dynamic where the material's all frayed. It looks like squirrels have been chewing on it or whatever. Like, clearly that's not going to have anywhere near its original capacity, holding power or function in that. So fortunately, our annual renewal process, when the consulting arborists get all their renewals for services queued up for them over the winter, there's a reminder to visit trees with cable installations. And whether we do that or not, that's another story. But there's a process in place to queue that up to remind us about sites that should be visited. Okay, next. Another time when we probably shouldn't be cable, or actually definitely should not be cabling, is when you have really clear evidence of decay in the root plate, because you could do everything possible to support the crown, hold that together, but if the foundation of the house, so to speak, is not sound, then the whole tree blows over. Maybe actually the cable system was so good it held the crown together that it helped to act like a lever to pull the root plate right out of the ground because of this decay. So, really a risk assessment. That's why there's things in place like this ISA sheet, that it makes you go through a very thorough diagnostic process for the tree to see every possible point of failure with it and take that into account. Okay, next. That next one, okay, yeah.
Yep.
Or where you have clear evidence of decay in the stem, especially with cavities. That's on the left. I think that was a Courtney picture she sent me of a Utapelicanker, technically not a decay, but with a stem that's that compromised. Like a stem could be completely hollow but still have some structural integrity. But once you start getting cavities within that, then the cylinder is compromised, and it's not going to be able to have anywhere near the holding power or strength. So, this would be another case of, you could put the best cabling system in the crown of this tree, but that's not going to hold up. The stem itself could fail, and then you don't really have any advantage gained at that point. Okay, next slide. Or clear evidence of decay in the crown, particularly at the union in question. This is a picture I just caught in Minnetonka at Big Willow Park on Friday afternoon, like where you've got other trees or weeds or stuff growing from within the union. That's a pretty clear indicator. Like, there's so much spongy, composty, decay stuff in there that plants and stuff are growing out of there. Like, good indicator stuff's not going on very well inside that union. Or there's, the fruiting bodies of decay fungi. We've started to get really tuned into that. Or you can see in many cases, especially willows are good at this, where they make root tissue growing out of the callus that's trying to grow around a crack, and inside the crack is the decayed innards of the tree. And if you see that in a tree, like inside that union where root tissue is growing, as those grow, they can actually exert pressure to expand the crack. So not a good candidate to cable in that case also. Okay, next slide. So another tool in the toolbox, so to speak, for mitigation is reduction pruning, with the objective of reducing the load and the failure potential. So that's often used in combination with cabling. It's not like you have to just cable or have to just reduction prune. Like, they can be standalone options, but why not combine them both to, increase the effectiveness if possible. And reduction pruning, will often use it for directional pruning as well. Like if we want to clear something away from a building or whatever, or this might be, as Wes gets to his part, like directional pruning to open up a path where the cable needs to run through. So you might be able to achieve a couple of objectives at the same time with a reduction cut. Okay, next. So this is pulled straight from Ed Gilman, the advantage of reduction cuts and the effect on leverage and load and stress on the tree. And he points out, like, if you have a choice of making a thinning cut like closer in to the point of origin of the main branch, or a reduction cut further out, there's a really great difference. Like if the branch is of the same mass, like what's the effect on the load? So if we move to the next slide, that'll be explained. Like, it's a function of, well, 25 feet out is where the cut would be on that thinning cut. And if it's 1,000-pound branch, it's 25 feet times 1,000 pounds. You get a reduction in load of 25,000 foot-pounds. But if you move out 40 feet to where it's a reduction cut, then you have 40 feet times 1,000, and you have a reduction in the load of 40,000 foot-pounds. So a difference of 15,000 foot-pounds just by placing the cut in a different location, like further out on the end of that lever, makes a huge difference. So Gilman's done, a whole lifetime of research on this kind of thing, of how to prune trees to get the most effective structural advantage within crowns of trees. Okay, next. And the result of it is multiple levels of benefit. Like, firstly, I noted you get the load on the limb is reduced just by reducing the length of the lever on the arm of that branch. And then secondary benefits come from that, like the branches that are left behind can make smaller waves that break up the bigger oscillations that are whipping along that limb. And then further following that, then those branches that now have more access to light and the apical dominance is removed, the secondary branches grow more, they capture more energy, and they feed into increase the taper on that limb, so they strengthen the limb. So that's why I call it mechanical and biological benefits from reduction cuts. You're just longer term building the structure of that tree and using the hormonal and biological means to support that. Okay, next.
All right.
Now, queuing it up for you, Wes.
Yep. So that brings it to, now that we've identified that we have a tree or a limb that poses a risk to, property, human life, what have you, we can go with reduction pruning, which is great. Reduction pruning, I always feel, should be done in conjunction. If you're going to do a cable, you should be doing reduction pruning, if applicable, on that. So you're reducing the load to make your system more successful. But the first thing we would do for support system to mitigate our risk would be installing a cabling system. And definition of cabling is the installation of a steel wire rope steel strand, or synthetic fiber system within a tree between branches or leaders to provide supplemental support. And then candidates for cabling. The number one reason why an arborist would put a support plan together is because the tree has a weak union. Weak unions can come in several different types. The first being included bark. Oh, that didn't go through. Sorry. There we go. Included bark is defined as bark that becomes embedded in a union between the branch and the trunk or between codominant stems. In young trees, an arborist can correct this by reducing one stem to later remove, or if small enough, removal when pruning. If the homeowner doesn't take care of the union in a young tree, it will start to push against each other and form a split. Water can also then get in between the union and form decay, resulting in a limb failure. If removal of the limb would cause more harm to the tree, we can reduce the limb to be supported or both and install a cabling support system in there. All right, so the next type of weak union, good candidate would be your codominant or multi-dominant trees. Not all codominant stems have included bark. According to Ed Gilman, if you don't know who Ed Gilman is, he is a retired professor as of now from the University of Florida State. He's done a lot of research in structural pruning, and then just the structure of trees, kind of the biomechanics of trees itself. And he states attached branch diameter, if the attached branch diameter is 50% or more of the trunk or parent branch, it will have a weaker attachment point and is prone to later failure in life. So like in the picture, we see this very common in our urban forest, where you'll have multi-codominant stems, all coming from kind of the same junction in there. And those aren't as attached as well as like some of those smaller branches. Let me see if I get my mouse over here. So like these big unions don't have as good attachment point compared to these smaller unions coming off of here. Something over here. And then let's see. And then a majority of our urban deciduous trees have some form of codominant stems, and that's due to just being able to grow really fast, I guess, in open light. They're not competing with other trees surrounding them. And some of those trees, genetically, they lack the apical dominance, strong apical dominance. So you just have kind of all these kind of stems growing up and competing with themselves and then later breaking out. Split unions. So the unions that have split away from the parent branch or trunk can be supported to extend the lifespan of the tree. This is a reactive step, and consideration of full limb removal needs to be taken into account if a limb poses a risk to the public or homeowner or infrastructure at that point. Especially in this picture, this was a recent one. There's already a lot of that decay already going down into that stem, a lot of that kind of nice compost area. That decay is always going to still be present in there. It's just going to be mitigating and maybe extending that life of that tree by 5-10 years on that. That's hard to say, and then decayed unions. So unions showing signs of decay can be supported with a support system to extend the life. Just like a split union, we need to factor in what risk we are willing to accept if or when the union fails. The support system will not, like I said, stop the decay process of that union, and regular inspection should be done to reassess the situation. So in this picture, this is actually from my house. I actually need to cable my tree. This is a honey locust. Big inclusion right here. You can start seeing that this is wet here. This is a very dry day. Now, obviously it's not from today, but it's been drought. This always kind of has moisture in here. So it's not to decay to the point of where it's falling apart, but there is decay active in that tree, in that inclusion there. I actually do sometimes get little weeds that grow out of this little section up here. You can see it's already kind of starting to crack a little bit and push against each other. So those would be trees that if you do see decay or seeing that kind of wet area in there, you can assume there's probably decay in there, and that would be a candidate for cabling to support that and maybe extend that life of that tree. And then the last weak union we'll talk about is overextended limbs. These limbs can break at the union because they have unproportionate amount of weight at the end of the limb, creating a very high load at the union. So the farther this is out, the weight is out here. We call that lion's tailing when we prune it like that. This can naturally happen in trees also that do have those multi-codominant stems. They're just shading each other out. They might be vertical or horizontal. Over pruning can cause that. It's extending every time you're cutting off stuff down here. This branch is going to extend more and more out. And then you're left with this big load out on the tip of the tree. The longer this branch is, the more pressure that's going to be on the union back here. And so even for laterals, you can put bracing systems in or cabling systems in to support that. If it's over like a pathway, if it's low enough, you could prop it, but we're not going to really get into props. But you can set up. It doesn't have to be vertical stems that we're supporting. And if you guys have questions, feel free to throw it in the chat. I'll try to get to it. I don't see anyone on screen because it kind of takes up my screen to do it. Or just speak up, unmute yourself, speak up like, hey, I got a question, I'm totally fine with that. And then another candidate would be limbs that threaten property or people or property. So they might not be like bad unions in a sense where like it's a hazard at the moment, but it could just be a high traffic area, and the likelihood or the city or the park might want to mitigate, any limb failure, being that it might be a low extended limb that they might prop or put a cable system into it to support it, just so they can kind of lessen and mitigate any risk from that tree. In review, so candidates for cabling would be most likely weak union connection. So that's included bark, codominant or multi-dominant stems, split unions, decayed unions, overextended growing limbs or lion's tails, as we like to call them, or limbs that threaten people or property. So there are two types of cables that we use at Rainbow Tree Care. So the first one is a dynamic cable, and the second one is steel cables or static cables. So dynamic cables have advantages and disadvantages. Dynamic cables do not go through the wood, so it's less invasive of a system. It also limits the amount of decay from the cabling system. One very important aspect of a dynamic system is that the fact the tree can move naturally. We install them with slacks so that the tree can move freely up to a certain point. While the tree is still able to move, this keeps a natural dampening effect of it. So dampening, if you aren't aware or if you're newer to arboriculture, it's the effect of if the tree starts blowing, all of the other acting limbs are also moving. That's taking the force out of it. So if you just have one stick, you're going to have a lot of force vibrating on that stick. But if you have 100 sticks, that one amount of force is going to be dispersed throughout all that. And it's going to kind of lessen the force that's onto the rip plate. That's why when Kent said it doesn't have a good rip plate, it might not be good for cabling, especially steel cabling in that sense, because, which I'll get to, I'll just take away the dampening effect. And then that tree would fail outright. The movement also builds strength within the union. So as the tree moves itself, it's creating more compaction wood at that union section and causing it to be stronger. Just like being in a wheelchair, if you don't use certain muscles, you're going to lose that strength. So if we just tighten it down, like on a steel cable, it actually won't be having that movement. It's not going to build up strength in that area. Dynamic cables also have some drawbacks. So one drawback is it loses strength over time due to UV light exposure. That's why regular inspections are necessary when installing these. They also have a potential to girdle what they're anchored around if installed improperly. So if they're installed too tightly around the limb, or if they're left too long and the limb then grows, it can actually girdle that area of the tree, and that will kill the top of the tree out. We do not want to have that happen. Some trees, structures do not have a union to anchor the cable to at the correct height. And we'll get into what correct height is in a little bit. So it kind of gives you, it's kind of limited in its location to where you can install those. And then also dynamic cables cannot support failed unions like cracks or splits. Can anyone tell me why we wouldn't want to use a dynamic cable for an actively split union? I'll get some water.
Anyone who's not named Kent.
Yeah.
So would it?
Yeah, go ahead.
It would have to be supporting a constant load.
Yes, exactly. And then was that Mac? Did you want to chime in? Or who? Dana? I'm sorry, I can't see anyone. I'm just
Yeah,
trying to go
that
with the voice.
I was gonna say, because allowing for the movement through the failed area would allow it to fail more.
Yes, exactly. Yeah, same thing. Dynamic cables are really used for unions that are pretty good, but could come under load later on. Maybe it's a normal wind like we just had that could make it fail, or maybe snow load in the winter that can make it fail, but they're not really designed for real problematic unions. So like you're deeply included, like the picture I showed of that locust union where it's already starting to decay. I probably wouldn't want to put a dynamic in there because I'm not going to want to have more movement in that union as it has. So yeah, so steel cables.
Hey,
is the
Wes.
other. Yeah, go ahead.
I guess one other disadvantage I was thinking about was can be squirrel magnets from time to time. The
Yes.
materials are good nesting material. I think what is our Guardian made out of?
Polypropylene. So
Polypropylene. Okay.
yeah, they love it.
So
Nice and soft.
I've seen them
Yep.
dismantled by squirrels.
Yes. Yeah, that's why regular inspections is crucial, especially if it's in like a high traffic area where you're trying to preserve the tree. In a sense, you know, if the cable, you put it in, but then you don't go back in 3 years, and it's already chewed up and that fails, that it's almost a loss, you know, of that tree. So moving on, our second system would be static or steel cabling systems. Steel cables also come with some advantages and disadvantages. They can support unions that have splits or cracks. Splits or cracks in the unions. You do not want any further movement of that area. Like decayed unions also, you don't really want any more moving around. The inspection period is a little bit longer on steel cables. Under A300s, it's about 3 to 5 years you can get away from inspections. Dynamic is much shorter, almost annually. I'd probably look at it depending on what kind of tree it is, just to see how it's holding up. And then placement. You can have very accurate placement in it. So placement of the cable in relation to the height is much easier to achieve, since you can pretty much put the anchor point almost anywhere you want to put it. Since you're drilling it in, you're actively making that anchor within the wood versus trying to find a union that's suitable at that height. So with the advantages comes some disadvantages. Steel cables are considered invasive, meaning you have to wound the tree to install them. Like any wound, be it pruning or drilling into the wood, it will decay from that area. It'll actually decay down the metal section and spread in that area. Decay can be very immense in certain species. Decay prone trees like linden might not be a good candidate for a steel cable if we don't need to put a steel cable into it. So if we can get away with doing a dynamic, we might want to use dynamic there. Other disadvantages would be it takes away from the dampening effect, like I said. So going back to that tree that failed at the root plate, if we were trying to support maybe a union that was like 15 feet up and we put 3 steel cables in there, that's actually going to take away a lot of the dampening effect of the tree, and it's actually going to vibrate harder down the stem. So we really have to do a full inspection of the tree before we put cables in, because I actually could make that whole tree fail versus just one limb fail because of having steel cables in it. And then if steel cables are installed too loosely, we'll also get a snapping effect that could possibly break limbs near the anchor point. So meaning that I have slack in my cable, the tree moves, it goes out to the end of the cable and it stops abruptly. It's not like a dynamic cordage on our dynamic cables where it has about a 10% elongation. There's pretty much 0 elongation with steel cable. If you have like a 50-mile-an-hour wind, it eases in and then snaps back at 50 miles an hour and stops abruptly. That can actually break it right at the anchor point. And then steel cables take a lot more gear to install and time to set them up. So that is another disadvantage versus dynamic. So tools and components. So dynamic cabling, tools we'll need for dynamic cables are, we use the all gear branch saver rope cable. Sheathing, which will protect the cable and tree from wear from the cable when it's touching it. We'll need a wire basket fid for the splicing of the cable. We're gonna need good scissors also. Your kind of paper scissors don't really cut it. This is probably polypropylene. And you're gonna want a holster to kind of house all that stuff so you're not, having to hold things in your hand while you're climbing around. Then also, I like to use tape. It's optional. Taping the end after you taper it to put it into the fid. It's a good option. Doesn't have to be used. That's why it's optional. And then some specs on the all gear branch saver. So it's made of polypropylene. It has 12 strands, hollow braid construction, meaning that there's no core into it. So if you push it together, you can actually have a little hole that's hollow inside. It comes in 3 different sizes, 3/4 inch, 1/2 inch, and 3/8 inch. We most commonly use the 3/4 inch variant, but we do have 3/8 in the shop for small ornamental trees. The MBS rating, so the minimum breaking strength, that's the minimum amount of force you need to break the cable in a straight pull, comes in at 10,600 pounds. And the working load limit, which is the load that you want the cable, or you don't want to go above this load if it's constant over the lifespan. So you kind of you have a margin of error in there. So your minimum breaking strength, if that cable sees 10,599 pounds, the next time that cable could easily break at 100 pounds, 300 pounds, 1,000 pounds. So if you're setting up these cabling projects, just be aware that the load, you really want to be more to that 2,000 pound load. And then under the manufacturer specs, the 3/4 inch branch saver should only be used for 14-inch diameter limbs or smaller. So that also will be a consideration. If we're trying to cable something much larger, we might want to move to a steel system instead. And obviously there's drawbacks and advantages for both of them. So steel cabling. So tools and components for steel cabling. We need a drill. obviously the battery too. That one didn't have one. We need a ship auger drill bit. So this is actually crucial. Ship auger drill bit is my mouse over there. As this little point here, that's going to drive it a little bit better into the tree. An angle grinder, which we use to cut the cable. We're going to need pliers. We're going to need a come along to do our tensioning. Deadeye sling used to attach the come along to the limb. And then a cable grip, which attaches to the cable, and then the come along attaches to this section here. So the components for a steel cable are made up of EHS or extra high strength cable. We use the 3/8 inch variant of it. The MBS is 15,400 pounds, and the working load limit is 3,800 pounds on that. We also use what's called, it's by a company Rig Guy. They're a wire stop. So that's a nut and a cone. It comes with that. Then also the cable stop cover, just to, hide it a little bit. And if your ropes are going to be rubbing across it, it's going to, make it so those cables aren't going to be cutting into you or into your gear. So placement of cables. So now to install cables properly, we need to have an understanding of the different configurations, cable configurations, why the height of the cable is important, how to select the best anchor points for our project, and then how the cable needs to be angled or aligned. So direct configuration is used when the leaders are opposite of each other. This allows the union to be compressed. It is not advised to direct cable adjacent leaders, since this will create a side loading on that union. So like in this picture, two codominants right in a line to each other, one single direct cable would suffice for that. Triangular configuration is commonly used with trees that have multiple codominant stems and maximum support is needed. Just like if you go back to your science classes back in elementary school or even middle school, triangles are some of the large or strongest geometry we have. And we can create those with a triangular configuration. You're supporting, say if we're supporting, over here, this limb here, since in this picture, these limbs kind of all come together. There maybe isn't one that's directly across from the other one. So instead of just doing these two limbs together like that, or it would be like that, we'd want to connect all three together to make maximum support onto this limb. So when these are pulling, and then you have these two connected, that's also going to support these two limbs. And we can also use that configuration if we don't have one large enough limb. So maybe the one that we're supporting is the largest codominant of the system. And then we have two smaller ones. We can now capture two smaller ones, be it direct or combining the third cable in there to support the whole system. And you can also have a configuration set up like that also. Like I was showing, if we're supporting this one, we need maximum support. Maybe this is huge. We're going to capture a triangle on this side and a triangle on this side.
Hey, Wes.
Yeah.
I've seen people use rigging plates for like a triangle. So it'd be like more of like a 3-pointed star.
Like a hub?
Yeah, right.
Yep,
So
I'll
it'd
get
be
to
like
that.
a
Yep.
thunder and then, like, running off of it. Have you had any thoughts on that, or?
So doing a hub configuration, I'll get to that in the next slide. Here. You're talking about having like a hub float?
Yeah, like a hub floating in the center, then like legs running off of it. So you
Yep.
can make like a, right.
Yeah, I'll get that after the box configuration. We'll talk about that. So box configuration, There we go. When you connect 4 or more limbs or leaders, maybe there's not a great section where you can, do a triangular configuration. This method should only be used when minimal direct support is needed. You're not going to get that great support. It's almost just kind of holding the whole system together. Not advised normally. A lot of times tree structures, you could get a triangular configuration in, but there are some species that this would be the only way to do it. And just be aware that it is only for minimal direct support. And then Daniel, you're kind of talking about this in a sense. So this is a hub and spoke configuration. It's pretty good for, I know a lot of people use this when you're doing steel and you don't want to add in more drill points than you need to. So you have, like you're saying, let me get my mouse over here. We have a ring in here. With our system, we do have the ability to buy a hub for the rig guy. And if you actually want to get real nitty gritty with it, if you go out and measure the angles, say if you're a sales arborist and you want to get the perfect cabling thing, because this is the best tree in the world and we have to preserve it, rig guy will actually machine the hub for you. So the cables are in perfect alignment on there. Obviously that's very rare, but that is an option. They do work with arborists around the country that do have some really historic trees and stuff like that need very specific cabling applications. So hub and spoke cabling consists of that kind of center attachment point, like I said, and then spans coming off of it. And that's more than obviously 3 or more leaders at that point. Was that what you were talking about, Daniel? To answer your question?
Yeah, because there's sometimes we get sent out and there'll be like 3 cables, but there's not a way to put 3 cables in to close the gap correctly. Like you're always twisting the tree.
Yeah,
So,
exactly.
like 1 cable or 2 cables would actually be better. But then just like the communication is like, we usually end up putting 3 in, but is it compromising the system or?
Yeah,
so not like that.
Yeah, it's super important to understand. We'll kind of dive in. That's why I want to do this cabling presentation. When we're all consulting on these projects, it's really important to look at the structure of the tree. And as a consulting arborist, look at what kind of configuration we're going to be utilizing, how that's going to load the tree. A lot of times we can do that from the ground, just looking at the formation of the union. And obviously tree structure they're not always like perfect, so a hub might be your best option in certain situations. And that's great because say if all these were like, maybe the unions are all different angles, you don't have a direct line across, this is still going to pull in direct line. So if this is back to this hub, this union is going to pull in direct line, that's going to pull in direct line and direct line. Obviously with our rig guy, that complicates things a little bit. We could even talk about down the road doing rig guy on one side, doing a different system back to a ring if we want to simplify that system. With cable grips are commonly used with a thimble and a cable grip around a steel ring. And that'll allow the tree to slide then a little bit,
Oh, and Wes, Ben had to jump, but he had a good point that he messaged me about, like the time to do the reduction pruning, if you're doing that to take the load off the crown, is before any of these cable systems go in.
Yes, yeah, and we'll get to that too. Yep.
Okay, great.
Yeah, so just to mention that now, since it's brought up, prune before you cable. That's number one. Say if you're deadwooding, reduction pruning, if it's spec'd for that, and which I would advise should be on, if we're trying to preserve that union, we should be doing some sort of reduction pruning. That's gonna reduce the load and just make our system a lot more successful. And someone has their hand raised, looks like. I don't know who, but go ahead.
It's me. Have you ever seen a hybrid where you're doing a box configuration and then two crosses where
Yes.
you're doing a,
Yeah, so back, let's go. So like on this one, so then you do cross, cross, right?
correct?
Yeah, so that's almost like a trip or double triangle configuration. Yes, that can vary if you need the maximum support in this system, like these are all weak or decaying. Maybe it's like this tree, you know, this is all falling apart. That would be a very good application of it. Al, that tree that big silver maple that I was on, we actually had that picture of that split. We kind of had that configuration. So we had, so this would be like the leader that was over the primary. We did a cable there, cable back to here. And then we took this one across to compress back in. So having those four and then doing a direct, because we had a direct union, but this one was pretty small here, doing a triangle and then doing a direct on it. Yeah, totally acceptable to do that. Hope that answered your question. Let's get going. All right. So the height placement of the cable. Does anyone else have any questions about configuration before I move on? Nope. All right. Feel free if you do have questions about stuff later that was mentioned before, feel free to just bring it up. The height placement of a cable is very important because if the cable is too low, the tree is going to put more force on the anchor point and potentially pull out or break the cable. If it is too high, the wood might be too small to support the limb or leader that you're trying to support. According to ANSI A300 cabling standards, the cable needs to be placed at a height roughly about 2/3 above the compromised area in relation to the height of the supported limb or leader. So sounds like a bunch of ANSI jargon, right? So 2/3 the height. We're not doing 2/3 the height from the base to the crown. So this was our defect. I should have this animated, so I'll just go back to here. That's our defect. And this is our supported limb is on the outside of it. We don't do 2/3 of the tallest one. We do 2/3 of the limb that we're trying to support because that is where our leverage, we need to support that. So if we have like a 50-foot limb on one side and then an 80-foot limb on the other side, we're supporting the 50-foot limb. We need to be at 2/3 on the 50-foot limb, not on the 80. Does that make sense? And then cabling height would be right about there. The rule can be adjusted down if necessary due to the structure of the tree and or holding capacity. So it's not, it has to be 2/3 because that's what someone said and it's etched in stone. Just like anything in tree work, it is a moving thing that is under ideal situations, 2/3 gives you the best leverage and holding capacity, as they found. But those things could change. Maybe at the 2/3 point, it branches off into tiny little, maybe it got topped, and at 2/3, we're into sucker sprouts that are decayed below. That might not be the best place to put a cable, being that we might pull it apart. So we might need to adjust it lower. I wouldn't go any lower than half, but half to 2/3 if you need to in there. And higher than 2/3, I would stay away from because you're probably just getting into much smaller wood. So when installing either, yeah.
Question. When you run into a situation, I saw a tree like that yesterday, a sugar maple, where 2/3 got me into like 5-inch, 6-inch diameter wood, like way too small. I wanted to put a steel cable in there.
Yep.
I thought by having to drop into more sizable wood, you would lose your leverage. So I recommended 2 cables, just one to be dropped down just lower. Is that a good recommendation?
So no, the funny thing is, Will, right? It was Will, right?
Yep.
Okay. There isn't a lot of good data on that. To be honest, this was one of the hardest presentations that I had to do to get, we all have this, what we've done our experiences. There is a lot of good hard data on those situations. I think it's up to us to understand the physics behind it, the leverage.
Right.
I think that in that case, that probably would have been the best, solution. You're kind of doubling up your support system in there.
Yep.
Someone had their hand raised. Want to rebuttal?
Yeah,
on
it's
that?
me again.
Yep.
I just have a question. It's been my experience that if there's an old cable in a tree from like a previous installation, maybe even from a previous company,
Mhm.
and it's arguably too low in the tree, or it was put in the tree when the tree was much younger, it's our practice to put our cable in at the height that we want to, but to not remove anything that's existing. Is that correct?
Yes, if it's steel. Dynamic, no. Right?
Correct.
So,
Yeah, I'm thinking steel. I'm
Yeah,
thinking
yeah.
a steel scenario.
so
And the
steel,
rationale is you don't want to ever undo a steel cable without removing the tree.
yes, depends on how low it is and what it, that's one of those things where you'd want to obviously install your new cable first. And if like the cable was loose or, it's probably going to be tight, super tight. It's probably not doing anything. I've seen those cables. It's almost like a brace in that sense. They have them so low in the tree. It really isn't supporting that union to its fullest. So it really isn't doing anything. So removing it would probably cause more decay, because you're opening that wound up if it's, sealed over. I would say leave it. Dynamic is a different situation. If the dynamic is tight, then that's not doing what it's supposed to do. It's not functioning properly. Yeah, does that make sense? I don't know if there is. I know I haven't been here that long. But from my experience doing cabling, we would normally leave the older cable in place. Oh, this is something that it's pulling in a wrong direction. We need to correct, let's say if they're side loading on it, but you're getting to unknowns at that point. If you're going to be removing a cable that maybe is supporting now that, like I said, that union could be weaker, and it's been trained to that section or being cabled like that. So I actually don't know. Is anyone else that's been here longer have insight on that, Kent?
I just have a thought.
Yeah, go
If
ahead.
it's J legs, we could cut the cable and leave the legs in, so
Yeah.
there wouldn't be any hole.
Yep. Yeah, you can definitely do that. Those super low cables, I don't feel like, especially when we put a higher cable up, aren't doing much advantage anyways. So it's really a horse apiece at that point,
Another gray area.
Yeah, like if it's super low, it probably isn't supporting the union anyways. So once we get the new cable installed and we have it in place, it's just there is that unknown. If you do cut that cable, if it's under load, that's where it gets a little iffy, because if it is under load or tight, that could cause an unforeseen issue. So on a safety standpoint, I would probably edge to leaving it because it's not really doing anything anyways, but there could be an unforeseen accident if it did have load. We cut it and now something fails, right?
Mm-hmm. And in those cases, if it's possible to do some kind of reduction pruning, would that give enough reduction of load where you could favorably change that? Maybe that's expecting too much, but
yeah, exactly. Like if you're putting a new cable in and you tighten it up and now the old cable is slacked, at that point, yeah, remove it. You're taking the load off, but no, good stuff.
I got a quick question.
Yeah.
So if you leave the dynamic cable in when it's tight, isn't that kind of like a death sentence for that lead that you wrapped around?
Yeah, that's what I'm saying. Dynamic is a totally different ballgame. You would want to take
Okay.
that out. Yeah. And you'd want to install, or you'd want to pre-tension everything on the tree first. So putting a come along. So if you're going to a dynamic replacement, you're going to need mechanical advantage, because you're not going to want to just cut a tight cable, because if it's tight, it could be a weak union that it could have failed, you know. The dynamic could have done its job at that point. So you need to do an inspection to make sure that union isn't failed, and we need a steel cable, and we're not just replacing with a dynamic, because if we, you know, if it's tight, there's a reason that it's tight. Is it just that it's overgrown and it's just the leaf weight, or did that union actually fail and now that cable is tight? And so if we tighten it up and then start slacking it off, that whole leader could fail, since we're putting it into a slack system. So those are things that need to take into account when we're doing our walkthroughs, especially on the CA side, to know like, hey, we got a dynamic cable that's tight. This union maybe looks compromised. We are going to switch into a steel. That's fine, because now we're tightening it up. We're compressing everything back together. We're putting in a steel cable. We're able to get slack off the dynamic, and then we're removing that dynamic so we don't further girdle that system. All right. A little tangent there, but that's good. That's good. That's what this train's about. So moving on. So placement of our cable. So our anchor point selection is super, super important. So installing either steel or dynamic cables, the anchor point of each cable is critical to the success of the support system. So being that at the height, the correct height of it, you know. The next section, we're going to go over what considerations we need to take into account when selecting our anchor points. So is the wood sound enough, and can the supporting leader support the load? This is going to be all like supporting, so just bear with me. Is there decay at or around the anchor point? Do we have a clear path for the cable to run? You know, do we have to take out some larger limbs? Is that what the client is aware of? You know, maybe like 3-inch, 4-inch limbs. You know, I'm not going to say we're taking out an 18-inch limb to get a cable in there. Can we capture the outside leaders to compress the unions near the anchor point? Is there an appropriate union at the height we need to install a dynamic cable? And how will a limb react if there is a failure at the union we are trying to support? And we'll go into deeper dives on each of these. So wood strength. We need to first inspect the leader or leaders we want to use for supporting the weaker limb. We need to look for any decay or defective areas on that supporting. So this is the supporting leader, right? Making sure it's going to be sound enough. And then we need to look at what angle is a supporting limb leader going to pull onto the supported limb or leader going to pull on the supporting leader. So we don't want to be side loading those unions or, you know, pulling them in a poor direction where it's going to fail. We always want to try to compress all unions. So here's a top-down view of a tree. In this example, the red arrows are the direction, and the blue arrows. The blue arrow is a leader that needs to be supported. So this is the direction of the unions. The red arrows and the blue arrows, what we're supporting, we're going to say, oh, my mouse is on the wrong screen. Just say we have a house up here. And it grows towards a home. The leader in direct line with the leader that needs to be supported is too small. So this one that would be great for just a direct cable, it's too small to support this guy, right? This is going to be our dominant stem, and they're worried about that because it's a big stem. Maybe it's overarching on their house. And then if we do a direct cable here, we're actually going to be side loading this one, right? So we might think, oh, just one cable, right? We're just supporting this, but we really need to look at the interior here. And things change, you know. So the best thing would be doing that triangular configuration to gather in some of this. So we're not 100% loading onto this side or 100% loading onto this side. We're splitting the load between there. And then having this connection here, we'll kind of make sure when it pulls, it's actually pulling. It's not going to pull perfectly in line, you know, it's going to pull more kind of bisecting that angle a little bit. So it's not gonna be perfect. Obviously, there's trade-offs, and not every tree is set up in a perfect world. So another consideration is the supporting leader, or another consideration is that the supporting leader can hold the necessary load needed to support the compromised limb or leader. If the limb is going to be supporting is bigger than any of the other leaders, like in that example, we need to plan on doing multiple cables in there, you know, attaching, getting multiple limbs to support that, you know, splitting that load up. The tighter our angle on our anchor point and our cables, the more it's going to be dispersed between those two limbs. The flatter we get out. So if you think about it, a 45-degree angle off of there is about 54% load on each of the cables. So if you have two cables coming out of 45, if we get out to 120, we have 1 times on each side of that. So same thing like doing hoisting for crane. This is just a different angle that you're looking at it. And then if we are doing a steel cable and there may be decay present, the stem needs to have at least 30% sound wood at the point of anchoring. This is important for the holding strength of that cable. So to determine how much sound wood we have, it is accomplished by 2 simple equations. For through bolts, like when we are installing bracing rods, which we'll get to later, we need to use the equation we need to add X and Y together, then divide by Z, and then times it by 100 if you want to get that percentage. X is the wood depth on the working side. So the working side would be the side that your bolt is holding into. So this would be your anchoring point. So the rod would be going through, and then your nut and washer would be on this side. And then Y is the depth on the opposite side of that. And Z is a total trunk or branch diameter, not including the bark. Some species like cottonwood can have bark that is, you know, 1/2 inch thick. So we got to take that out of the equation. For dead end systems, the steel cable that like we use needs this equation. So it's X divided by Z times 100. I know, get your math brains on this morning. It's not too complicated. All we're doing is we're taking, so we have a rig guy cable system, cables coming in this direction, coming across, anchoring back here. We don't need this for supporting. We just need this side for supporting that. So we need to make sure this is 30% of it on here. It's not 15 and 15 to make that 30%. We need at least 30% on the anchor side. So we take X. So if we do it, as we got 3 inches sound wood, the total diameter is 10. So 3 divided by 10 is 0.3. And then times it by 100 to get your percentage. And that's going to be kind of hard to see, right? How do we know that? You know, we're up there drilling. We're not looking at a cross section like in this picture. Like, so we have to kind of use our educated guesses, right? When drilling through wood, if we drill slow enough, we'll feel a change in pressure we need to apply to that drill to advance it. If the drill pops, like you just get right through maybe the cambium layer, some very small sapwood that pops straight through into the center, we might want to start thinking about, we need to maybe move up and down and kind of look at the tree. Like, is there an old pruning cut near it? Is there an old tear out near it where decay came into that wood and is causing that? Or we might just, we can't set up a system like that because we need wood, right? Holding that. So if it's very thin, it's just going to break through and punch through. Dynamic is different though, because it's encompassing around the entire thing. So if it's a small enough limb, and we can get away with using a dynamic, we could use a dynamic on that.
About the only way we could get some level of certainty about what that holding wood is pre-drill it with resistograph.
Yeah, exactly. I was going to get into that, but that's a whole nother road.
Yeah, exactly.
But to
That's,
get the real critical, but like if you've
Yeah.
ever drilled through something, you can pretty much feel like, okay, there is decay here. And kind of feel how far you had to drill in with that pressure, and then when the pressure stopped. So if you're actually, if you're, and it's not like you're just going to randomly find decay. You can, but like you might have an indication where there is an old pruning cut, maybe a larger one. And you're like, okay, there might be decay here. This is the height. This is the only thing I have. Now I need to take that into account. I'm going to drill slow and kind of count how the distance I'm drilling in before I feel it getting softer. So you can kind of do an estimate on that section.
that plus like the quality of the shavings coming out.
Yeah.
It changes from nice, clean white wood to crumbly brown stuff or absence.
Yeah, just absence. Yeah, exactly. All right, so anchor point selection. So we need a clear path, right? It's important to have a clear path from one anchor point to the other. We don't want any deflection in our cable, so we don't want another limb pressing on it. This can reduce the holding capacity of the cable. And we might not, and we also don't want the cable rubbing on it because that could damage the tree, wound it, and or destroy the cable, especially if it's like a dynamic cable. We might need to remove limbs to get a clear path if that is the only option, or change our configuration to overcome that. So capturing the outside leaders. So when we can, we want to capture, so this is this one tree. This is great artistic. So this is one tree. Our union that we're supporting is way down here. We want to try to capture these outside unions in here. Why would we want to do that? That's a question for anyone that wants to speak up.
If you're capturing the inside, you're just tensioning the inside ones, and then you could be pulling against unions higher in the canopy, which could also fail.
Yeah, exactly. Pretty much like a wishbone effect on that. So we have our inclusion down here. We're trying to support it. This is going to be about 2/3 right here, or maybe 2/3 is going to be way up here. What we can do, we would want to, so if we cabled here, like I said, it's going to pull and probably separate those limbs because these are included. So if we couldn't cable below this, say if this was like below half, these are, just use your imagination. This was below half. These were in direct line with each other. This could be a situation where we do a support cable above this union to support it, and a support cable above this union to support it, and then cable these together. So now we have 3 cables in there where we would just want one, ideally, because we're trying to support this, but obviously this tree has more defects farther up the tree. We see this all the time, especially, silver maples and stuff like that. If you can, I have drilled through these interior limbs straight through, feed the cable through, drill through the other one, and attach it. So now we have a through, drilled in, attached back here. If you can, that's why we have to think about 2/3, like maybe this is 2/3 height. We can't get so ingrained in, oh, it has to be 2/3. I'm going to get a tape measure out, because this would be a way better application for that cable if we could come below that union in there. And looking at it, so not even like that one where it's so extreme where they're both across. if you can get through here and you have clear path, get to the back sides of those. Even if they're nice unions, always come to the back sides. So you're compressing that union into itself. All right, so when selecting a union to install a dynamic cable, we can run into a few problems. The first problem would be we don't have a union at the 2/3 height mark, right? We've all seen this. We have lines tailed trees that, you have a union super low and then you have a small union super high. We run into that just climbing, trying to find our anchor points. In this case, we can adjust the height to lower in the tree, but we do want to stay above that halfway point in there to support the halfway point. Well, we don't want to go really above that 2/3 if the stem wood is not sufficient. So if we could go above 2/3, if it's like a weirdly shaped tree where it's still huge wood, all the way up, we could adjust that, but staying within that 2/3 to half area is ideal. We also need to look at how tight the union is that we're trying to capture. If it's a super tight union, what can happen is the cable, so like this, maybe it's a tighter union. Once this branch starts growing, this can actually capture this side of the cable. Now that this is maybe pinched in here, that's actually going to change the pull of the entire cable system and the splice itself. You're going to have more load on this side of the cable versus evenly distributed against that splice. And that could cause failure or, just not how we intended the entire system to work. So that's why if we are only having super tight unions, we might want to go back periodically to adjust that cable. And lastly, we need a large enough lateral limb to hold that cable in place, right? So we really want to get to a point where it's probably inch and a half really lateral to be able to support it. We don't want to just have some little tiny sprout holding it up, because this tree can still move, right? If that limb back here moves sideways, that's goes this way into where that sprout is, that's going to rotate that entire cable. Could be putting force onto that tiny sprout, potentially just breaking it. It's like a 1/4 inch, half-inch sprout, breaking it. Now that cable just slides all the way down the tree. So we really need to be setting it up for success from the get-go. All right, and then the final consideration is for our anchor point or configuration is how the limb, if it fails, will move. Just like any rigging situation, we don't want to set up a configuration that pulls the failed limb into a structure or high value property or traffic. So doing a triangular configuration normally can stabilize that because you're stabilizing it between 2 points on opposite sides. So if it fails, it's not going to move left or right. If you just have a direct cable, you really need to watch how you're anchoring that, how it's going to swing. Is it going to swing into the house and pretty much just defeat the purpose of having the cable in the first place? Maybe it was just like a weak union over the yard, and now we did a direct cable on one side, and when that union fails or limb fails, the cable catches it, swings it right into the house. We need to look for that and set up our rigging so we prevent those swings. All right. Any questions on our anchor point kind of selection? We're almost done. Only 13 more slides. All right, so when we're installing multiple anchors, and this is really steel anchors in this picture, we need to be a distance apart greater than the diameter of the wood you're installing it into. So if you have like 10-inch wood, it needs to be 10 inches apart, or 12 inches, whichever is less. They also need to be offset and not parallel. In this picture, you can see how they staggered all three of the cables. It's kind of a poor picture, but You got one low here, got another one higher back there, and this one below that one. So if we are doing a configuration, we need to have them all separated by that distance of the diameter of wood. Excuse me. We don't want to be putting them, steel cables, putting them onto the same. We can't even do it on our system, so I didn't really put a picture in there. But you don't want to have, if you had a thimble system like a J-leg, you don't want to have two cables off of the same J-leg. I bet some people on here don't even know what that is, but that's fine. Our system prevents it, so I didn't really want to spend too much time on it.
Wes, you're saying that's only for steel cable, correct? Or is it for dynamic as well?
That's only steel cables, yeah.
Okay.
Because that's due to decay, strength of the wood, because now you're utilizing, so if you have two drill points really close to together, now we just drilled in, we're reducing the amount of holding wood between those. And then you're actually opening up. So decay will run down the cable or down the metal of it. And if you have them too close, it's just going to connect. So that's why they say to space them out the diameter of the wood. So you're still having the strength of the wood there. So it's almost equal, you know, the strength of the wood still, and then offsetting them also, not having them parallel. So it's not pulling the same direction.
Got it.
Most
Okay.
times you're not doing a cable direct, two cables direct in line, unlike Will's example, you would be. So you'd want to do, if it's large enough, one off here, one down here. Most time you're doing one here, then one around the other side to capture a limb that's out this way or this way. So when installing multiple anchors, so dynamic cables, you can install at the same union. That's perfectly fine. So angle and alignment of your cable. So the angle of a cable installation should be perpendicular to an imaginary line bisecting the angle between the tree parts being cabled, as you can see in the picture on the left. So our union is coming up this way. You see a lot of times people just go straight across, boom, right there. If this is a very horizontal limb out here, we want an imaginary line 90 degrees off of that and perpendicular from there. So it's actually kind of at a downward angle on there. And this is straight from ANSI A300s. This picture's actually from there too. Most of these pictures are. So it's also important to have alignment of your cable. So picture over here, making sure, so if you're drilling in, you're aligned to where the cable is going to go and anchor. So you're not loading. So this is a through bolt in here. You're not loading sideways on that through bolt because you're not going to be side loading your anchor point. You want to be straight in line. The same thing with our rig guides. You don't want to be coming out and then bending into it. So a trick I've used before, and we should maybe get into this. Take a laser pointer, tape it to the top of your drill, facing backwards. You can sight down to where your anchor point is going to be then. That's probably some of the hardest. If you're doing long spans, trying to drill and look behind you to see if your drill line is in line with what you're going to be drilling to. So you do your first one, and then you sight your second one in line with that. All right, any questions on cabling before I get into the bracing section? Any tricks you guys pulled up? And this won't be going in, like I said, won't be going into installation since we'll be doing 3 hours in field.
Wes, you've got the seasonal timing of the different kinds of systems, right? That's coming
Yes.
up.
Yes.
Okay.
Yep.
Good.
That'll be like the plan overview of everything. Yep. All right. So if no, so bracing definition is to install steel rods in limbs, leaders, or trunks to provide support for a junction. So candidates for bracing. The main reason why we would need to install a bracing rod in a tree is for a split or cracked union, or maybe a compromised union, maybe decay, but not too much decay. So there's a fine line in there. So tools and components for our bracing. So tools we need is, I just said, a whole hog drill and a ship auger drill bit. The drill bit needs to be 1/16 of an inch to 1/8 of an inch larger than the rod we are installing. Because we might read on other things like doing smaller. We only use through bolt bracing. We don't do tree rods, threaded. So we use machine threaded rods, so they need to be larger, so they slide right through. We actually don't use kind of like a J leg, which is a leg threaded system. So I didn't really put that in here, which you would actually screw into the tree. It's more older style. They work just fine. But we do a through bolt. So your drill bit needs to be 1/16 of an inch to 1/8 of an inch larger. Try to be on the 1/16 of an inch. Less wood that we're disturbing, the less decay we're going to have, larger hole. And then for our 5/8 rods, we're going to need 11/16 inch bit. And I actually might have this wrong. I couldn't remember. So, we need an angle grinder, sorry. And then 2 wrenches. We need 1 1/16 inch wrench. Let me know if I'm wrong on that. I thought it was 1 1/16 inch wrench. Could be 15/16, but these to fit on that nut. Sorry. And then a ball peen hammer. So the hammer itself is going to be tapping the backside of the rod to mushroom it out so the nut can't fall off. And we'll get into all that installation and all the nitty gritty of like different tactics, stuff like that, how to actually do the installation. And then components we're going to need for bracing is, like I said, a machine threaded rod, and then 2 nuts and 2 washers. So sizing. So this is really important when we're doing bracing. This is straight from the ANSI A300 cable and bracing standards. So diameter at the brace in inches. So if it's less than 5 inches, we're using a 1/4 inch rod in there. So we'll get into kind of plan, but this is important for when you're consulting arborists on site. We don't just use 5/8 rods on everything, because if you can see in the table here, 5-inch rods, 5/8 inch rods are for 14 to 20 inch diameter limbs at the bracing point. And we'll get into where the bracing point is in a little bit. So knowing where it is, it's easy enough for us to, get this stuff. It's just like a crucial thing, like where it's like a smaller thing, like we can go to Fastenal pretty easily, pick up exactly what we need day of or day before. We know that's on the books and it's in our job notes that it's a 5-inch limb or it's the 8-inch, we can get the correct sizing. You don't want to, the reason is smaller a hole, or if you're drilling too big of a hole in a diameter, you're reducing the holding capacity of that wood. So that's why you have brace rod diameter to diameter of the bracing area. Hope that makes sense. And then we also have a minimum number of rods. So when we're getting into that larger wood, we're normally probably bracing between the 8 to 20 inch wood at bracing point. If it is a split or include bark, we're going to need at least 2 rods, and we'll get into where we place those rods. But if there's no apparent split, we're just kind of adding an extra brace, and they're just for safety concern. We just need 1. If we start getting into larger wood, so your 20 to 40 inch leaders, maybe there's cracked union right there, we're going to need 3, and then an additional rod at every 8 inches in excess of 30 inches. So you need 4 at 38 inches, right? If it's going to be a split, because most of the time when we're bracing is because it is split or included, bark, like very severely included, decay, it's cracking. It's a reactive step that we're taking to preserve that tree. So when a single bolt is being used, we need to place it above the union by 1 to 2 times the branch diameter. So if we have a 10-inch diameter limb, we need to install the bolt 10 to 20 inches above that union. So multiple bolts. So now we're getting kind of into larger wood or a larger defect. When using multiple bolts to hold the split union together or a bad inclusion, we can set up a couple different configurations. So we have a multi-bolt configs are made up of 1 bolt above the union. That's always that way. We always have 1 bolt above the union. And then bolts down the split or inclusion spaced out at the equal distance to the diameter, just like installing steel cable anchors, same thing, equal to the diameter or 12 inches or whichever is smaller, evenly as possible the length of the split or inclusion. So if it's a deep split, we might need 3, 4, 5 bolts to support that whole thing. And then first configuration would be a parallel configuration, like in the picture. That is a parallel config will align the bolts vertically and directionally. So meaning each bolt is perfectly in line, straight down. So it's a little different from doing cable supports because these are actually vertically in line. So one after the other, straight down. And then directionally means that they're going in the same direction. And we'll get into other configurations that change that. And then alternating configuration. So maybe the split kind of moves. Obviously, you can see here kind of swivels a little bit. In alternating configuration, you still align the bolts in the same direction. So align them directionally. So they're going on the x-axis the same, each bolt. And then you slightly move them side to side down the crack vertically. Any questions on that? Does that make sense? Yeah. Okay. All right, so multiple bolts crossing configuration. So the crossing configuration is made up of 2 or more bolts that are not in alignment vertically or directionally. So this one's pretty good. I actually prefer to do, well, smaller trees you can do parallel, that's fine. Larger kind of, so this is the kind of that 3-stem section. It all kind of split apart. You can put your bolts in so it's not aligned vertically or directionally. So your first bolt down the stem, that's down the stem, you know, down the crack section. Obviously, you still have your bolts above like they have in that picture. And then you have one going straight in, and then maybe you take another one at a 45-degree angle off that other one and then swap down. So you're kind of doing this kind of crisscross pattern down that stem. All right, so putting it all together, right? So now that we should have a pretty good understanding of cabling and bracing, kind of the functions and the standards, we need to put it into practice and make plans that are consistent with our A300 standards. And if you don't have a 2013 version of the ANSI standards, I did find a PDF one. I don't know, someone pirated it, I guess. Really good. So if you need it, I can send that out to you. If you ever want to take a look at it, just the cabling and bracing, maybe to reference, stuff like that, I can definitely send that out. The first things we need to consider is doing reduction pruning on the leader or limb we want to cable. So I really want to hone because we don't do enough of that, I feel. If we know we have a defect and we're doing a steel cable, like we know that this union is defective, we're trying to support it, we should be doing some sort of reduction pruning because that's going to reduce so much amount of load. As you saw from Kent's slides, taking that weight off at the tip will reduce that force at that union by a ton. So we should be doing that just to reduce it, you know, not like topping or anything like that. We all know what good reduction looks like, you know, 1-inch, 2-inch cuts. nothing more than 4 inches, areas of cutting, because now we're just creating decay. And then, let's see, sorry, I'm getting lost in my notes. Reduction pruning, because it'll greatly reduce that load. When choosing between dynamic and steel, we need to consider the conditions of the union we are trying to support. So dynamic cables should only be used to support sound unions that might fail should there be, out of the norm load due to wind or snow, or maybe overextended limbs. The union's fine, but it's been pruned up so many times, it's overextended, it's lion's tailed. We might need to support that. But we still want things to move, right? So dynamic cables should also only be installed when the tree is in full leaf. So we don't make the cable too taut and take away from the ability for the tree to move freely. That's super important. So we should really only be doing them in full leaf. There are situations where we might have to do them in the winter and we're going to have to compensate, but that's more of a guessing game. And if we are doing it in the winter, we should probably then inspect that cable if we had to, for some reason, inspect that cable. So maybe it's like an oak prune or something, and the client just wanted to get it all done, during the winter because they're like that. We might want to inspect that cable come summertime to see how it tightened up with the load of the leaves on it, and then maybe replace. So it's just better just do it full leaf anyways. Client side, they're money wise, that's going to cost them, obviously. Steel cables, on the other hand, should be done when it's in dormant. Reason being is if we do that in full leaf and it goes dormant, we're losing weight on those limbs. That steel cable could then become slacked. And if you have a slack steel cable, like I said before, you get a snapping effect. When that tree moves, it moves a certain amount and then stops abruptly. And it's shock loads, right? So a lot of times, like I said before, that could now shock load right at the anchor point. And it's probably going to break out near that anchor point if it's a strong enough shock load. Sorry, I'm just lost my huge notes here.
So basically it's like dynamic goes in when the tree is dynamic, i.e. growing season, static goes in when the tree is static, or other words, dormant season.
Yeah. Yep. And then with steel cables, we're really trying to limit any movement. So when we're selecting if we're going to opt for a steel, it's because we do have a defect. It's more of a reactive, I guess, type of cabling versus dynamic is more of the proactive. There could be, an issue later in life. So we're just going to, maybe give it some support. And then let's see here. So bracing plans should include reduction pruning. So if we have, even if it's, codominant stem, inclusion, split, right? Equal sides. We might still want to do reduction on both sides of that. We're reducing that load at that union because that's why it's failing, it's splitting apart. So doing a reduction maintenance plan on that tree if they want a long term. All depends on when we get to that split too, if we can actually get it together. If it's been sitting for a year, it's unlikely because the fibers are going to be all dried out. So that's another consideration, doing that reduction, because now we just have a defective split union, reducing that load, and then doing a reduction plan moving forward for that tree. And then also we need to be installing a steel cable with a brace. The brace itself is great, but the steel cable being higher up is going to give it that advantage on that leverage to hold it in place. The bracing is really just to hold that cracked section from cracking any farther. Yep, you get your hand raised.
Yeah, this is Lieben. For the I think we're getting new pricing. I don't think we've ever had good pricing model for bracing. So there's a request to make sure that that's included. And then I've always shied away. I don't do a lot of aggressive bracing because it feels a little invasive. So I don't, you didn't really talk about when bracing is, you know, recommended or you know, yeah,
So
should be prescribed.
So recommended would be if you do have an active split. So that's from the ISA when they write. So that's the other thing. There's not, so it is very invasive. So the point of it being is you're not gonna, I wouldn't put a brace myself. I wouldn't put a brace in if I have sound wood and there's a potential. Just because it is so invasive. There are arborists that do that around the country, around the world. You know, there's other people do bracing in other countries way more often than what we do in the US. But if you do have an active split, a cable itself, if it's still actively splitting, might stop it from splitting, but it could shear off, right? So we got to look at how, if we do have an active split, you know, if it's opened up, we're talking about like storm, like it opened up, we have like a couple of inches open up. That's where I'd start doing bracing if we want to save that. And that is only if the client is aware that this is not 100% going to save this, because they can shear off. It is just that point of like, it's an added, I guess, a little bit of an added safety in there.
Yeah, I always thought like if you imagine, you know, you support it with a cable up high, but you know, there's still pressure pulling away at the base. Like if you can imagine the butt end continuing to pull, then that's where you'd want it. But if that's not really likely, then I wouldn't. You know, that's the way I've always done it.
Yeah,
which
exactly.
Seems pretty rare to me, but okay.
Yeah, so like going back to that one big picture, we had that huge crack in there. That would be bolting, you know, if we had large enough tools to do that, and I'll get into that in a couple slides. But yeah, decay also is, so if you have, so that's another double-edged sword. So these are all compromises, right? If you have decay in there, that decay is always going to continue, and maybe that butt's going to fall off, right? So having a brace section above there to hold that butt into position might be a good opportunity, but then you're dealing with decay is going to run down the bolt itself. So they're all give and take. There's not a great option. If you're bracing, it's pretty much like, well, this is the only option we can do. You know, it's pretty much the last line, right? We do dynamic first because that's a proactive, you know, before something gets bad. Well, reduction pruning really should be your first, you know, if there's, you know, inclusions, stuff like that. But beyond that, dynamic, then steel, because now we're getting into a reactive portion. The inclusion's too big, it's starting to peel apart. There may be decay in that union, there's a defect, stuff like that. And then bracing is like, it pulled apart, we're just trying to, you know, fix that section. That's how I kind of see it. It's like those steps down that road. All right, so writing up a support plan. So this is really geared towards sales arborists. These are things I've gathered over the time being here, and some other from technicians, what they kind of want to see. So indicating which limbs needed to be supported. Sometimes we just get work orders that are just like, you know, 2 cables, and, you know, what is the plan? What, like the actual plan? What is the outcome we're trying to do? What limbs we're trying to support? Number of cables, obvious. That's normally pretty good. Number of cables and braces, and then configuration style. Adding that into your work plan write-up is huge, because that gives you, there's none of that like, well, just the technician will figure it out, or they'll see something. Most times I can see from the ground how I'm going to be supporting this limb. You know, there might be some minor adjustments where the anchor points are going to be based on the structure up in the canopy, but based on how you're looking at how you're going to support that one lead or multiple leaders, you can easily come up with a configuration plan style for it. And having that noted, I've actually, if you just, I know we talked about this and they'll probably be coming down the pipeline. We used to do hand-drawn maps, which were really good. We can import under ArborGold, and we're probably going to go into training. We were supposed to talk about that last week in our CATA meeting, but never came up, I guess. For cabling, just doing a above aerial view, 3 circles or whatever, where like the cables, like what we're trying to support, maybe like a house. We can take pictures of those handwritten, hand-drawn maps and upload them into the files of ArborGold. So technicians can see that. Really handy tool. I would just say probably in the job notes, if you're going to move forward before we have a plan, job notes say that there is files, because ArborGold isn't great about saying what it has, until you look at it. And then also approximate the length of cables or braces. So easy way to do that, step it off, look it up, like once you know your configuration plan, kind of knowing where the cable is going to be, you can just step it off. That's really helpful, knowing if we have enough cable with us. If it's like 30-foot spans, 20-foot spans, so we're not just running out of cable mid-job or having to like lug around 2 rolls of cabling with us. And same with braces. So big thing, we only have a 4-foot bit at the moment. So if we are bracing larger wood than that, that is something that should be indicated so we can get the right equipment on those job sites also. And then for review, we want to follow up with the tree and the system over time, what adjustments, replacements are needed. Like the goal is risk mitigation. We're never going to make something 100% safe. Then the tree support systems are just one tool in the toolbox, along with reduction pruning and restricting access. So I'm going to close with that. Does anyone have any questions, comments, concerns?
Daniel had a comment about propping or putting crutches under trees. Like, are we going to do that?
I would love to do that. There's actually a crabapple in Golden Valley that I've suggested to the homeowner that they prop.
Mm-hmm. I've seen it
because Davey has a stupid steel cable in it. And it looks stupid. I was like, you should take that out and just prop that limb.
Yeah, you see it out east and in European countries all over the place, but locally I've never really seen it. I don't know why we wouldn't.
Yeah, they normally have to be pretty low, low extended limbs. A lot of our trees don't have those because us in the US, we love cutting off everything below 14 feet. So clearing it up and making them like mosses. But yeah, like live oaks, I've seen that down south where they have long extended limbs.
We had one a few weeks ago where we were pruning the trees in the front yard and we walked around the back and they had big oaks and they had all the low limbs crutched.
Nice.
It was really cool.
Any questions? Is it still storming? Yes. So yeah, no one has questions. Like I said, installation nitty gritty stuff is going to be in 2 weeks in field at the West Shop. We'll get into all the different techniques of actually installing those different cabling and bracing systems. All right. Well, feel free to sign off. Oh, actually, GFs, did you want to do something? I know now it's kind of changed plans. Is Kevin on here?
Yeah, I'm on here. Yeah, we're gonna.
Do you want to go over that?
Yeah, we're gonna.
CAs, you can sign off if you want. Shoot me an email.
What?
I said CAs could sign off if they want.
Yeah, the CAs can sign up. This next information is for the techs here. Wes, can I screen share here?
I should be able to let you. Can you? Does it give you an option or do I need to?
Oh, yeah, it does.
Okay. Yeah, I didn't.
All right. Everyone can see this here. Right, Wes, you can see it? All right, so this is kind of just to communicate what the GFs and supervisor and maybe Brent and Troy are up to moving forward, and then just kind of remind everyone that we do have a tendency, or sorry, punctuality and attendance protocol or policy. So we're kind of bringing this back into people's the forefront, and I'll go through it. I'm going to read through it. I will send this out to everyone, and then we'll